Hey, Bobcats, it's Mr. Peterson. Today's awesome pile of awesomeness lesson deals with radical function inequalities. And by the end of this lesson, you should be able to graph radical function inequalities. I think that should probably just say radical inequalities, not radical function inequalities. So graphing radical inequalities, just again to review, when we have a radical function, that's a function that has a radical in it, so like a square root or a cube root. And just like linear functions, logarithmic functions, exponential functions, quadratic functions, they can have inequalities too, greater than, less than, or equal to, greater than or equal to, and so on. So let's just go ahead and graph this one. We want to graph the inequality y is less than the square root of x plus 2. All right, so just remember when we graph these, we want to choose values for our domain that will be perfect squares. So like 1, or excuse me, 0, 1, 4, and 9 would be good starting spots. So those are our x's and our y's over here. So so what we're going to do is we're going to treat this like it's y equals the square root of x plus 2. All right, so let's sub in some numbers. The square root of 0 is 0, plus 2 is 2. All right, sub in the 1. The square root of 1 is 1, plus 2 is 3. The square root of 4 is 2, plus 2 more is 4. And the square root of 9 is 3, plus 2 more is 5. So now we can graph, we can get a good idea what the graph of this will look like. So you would draw your axes. I'll come over here. All right, so we have 0, 2 on the graph, so that's over 0 up 2. We have over 1 up 3 on the graph, over 4 up 4 on the graph. There we go. Nope, right here. Nope, right here. My bad. And then over 9 up 5. There's 4, 5, 6, 7, 8, 9 up 5 right there. So here is our graph. We want to now we want to pretend that equal sign is really what it is, which is a less than sign. So with less than, we will use a dotted line. So we're going to do a dotted line. And we want to shade all of the numbers that are lower than that. So our graph will be all of these values down here. And we want to use the x-axis, the y-axis, excuse me, as our boundary. We wouldn't shade over here. That doesn't make sense in the context of this problem. So we use since our lowest value is 0, we stop there. All right, so why don't you guys try this one and this one. And we will see you in class today.